Hello everyone. This is the brief presentation on the project Geriatric Fall Detection and Protection based on IoT technology. Generally, fall detection and fall protection are two important aspects of ensuring the safety and well-being of individuals, particularly the elderly and those who are with mobility impairments. Fall detection refers to ability to identify when an individual has fallen, while fall protection involves taking steps to prevent falls and minimize their impact. There are several ways to detect falls, including wearable devices such as sensors or accelerometers that can detect sudden changes in motion or orientation. These devices can be integrated with alarm systems or other alert mechanisms to notify caregivers or emergency responders in the event of fall. These are the outline contents of this presentation. The falls can be are of different types like incidental falls from heights, falls on the same level caused by slipping or tripping, and falls from wheelchair overturns are commonplace phenomena associated with the serious injuries from impact with the ground. A wearable airbag device is a countermeasure applicable to all these types of incidents. Based on SVM filter, an embedded digital signal processing system is developed for real-time fall detection. We can also use a DMP, digital motion processor, for filtering the motions. The response time for the mechanical trigger is 0.133 seconds, which allows enough time for compressed air to be released before a person falls to the ground. Once a fall event is detected, the system can trigger a response. This is a general block diagram of the prototype presented. The battery here used is a 3.7 volt 2600 milliampere battery. It is used to hold the power. USB connector is used for charging the battery. The node MCU is used along with the MPU6050 sensor. MPU6050 sensor is a single chip integrated with 3-axis gyroscope and 3-axis accelerometer. It is connected to a servo motor. Servo motor is used for controlling the flow of the CO2 gas into the airbag. This connector connects the CO2 cartridges and servo motor. CO2 cartridges are the medium of inflating the airbag. This is the airbag we used. The whole working of the system is based on the measurements taken by the MPU6050 sensor that includes accelerometer values and gyroscope values in 3D direction, that is X, Y and Z axis directions. The algorithm gives the overview of the working of design prototype. When the fall is detected, the sensor gets initialized and then sensor records the readings of X, Y and Z parameters. Then the threshold value is checked whether the threshold is greater than 10 or not. If the threshold is greater than 10, the servo motor is triggered, which opens the valve of inflator through which CO2 gas ejects into the airbag. And if the threshold value is less than 10, the servo motor is not triggered and CO2 does not eject. The response time of the airbag is 0.133 seconds. This is the basic connection of the fall detection. Using MPU6050 sensor on a Gizmo 6 board, we used a Arduino software to test this connection. This is the image of the prototype when there is no inflation, that is, before the ejection of CO2 gas into the airbag. This is the image of the final output of the prototype, that is, the airbag is inflated with CO2 gas with the taken threshold values. To conclude, this project allows us to draw perspectives regarding the use of newer technologies for this system. Fall detection and protection using airbags is a relatively new area of research that has shown promising results. The concept involves using airbags that reduces the risk of fall injury. The use of airbag in fall detection has several potential advantages, including reduced risk of injury, increased comfort, and ease of use. The main objectives of these projects are to develop and evaluate accurate and reliable fall detection algorithms, to design and evaluate effective fall protection devices and strategies, to investigate the effectiveness of fall detection and protection systems in real-world settings, to understand the needs and preferences of users and caregivers, to explore the potential of new technologies in fall detection and protection. The main aim of this project is to develop a system which detects a fall of a person. When it does that, the Arduino Nano which is used here gets the input and enables the CO2 cartridges with which balloon gets or airbag gets inflated, providing safety to the person, ensuring the well-being of the person. We can extend the project by adding GPS module and Wi-Fi module in the future. Whenever a fall is detected, automatically the system can send a mail or some message alerting about the fall of the particular person to the person's relative or a caretaker along with their location details. So this is the end of the short presentation on the project Geriatric Fall Detection and Protection based on IoT technology. Thank you.